Let us discuss about capillarity. A capillary is a tube with a narrow pore. The liquid in a capillary either ascends or descends, which depends upon if the liquid is wetting or non-wetting, respectively. So, in wetting liquids like water, it ascends in a capillary and the mercury descends in capillary. This rise or fall of liquid in a capillary is called as capillarity. So, capillarity is a phenomenon of rise or fall of a liquid in a capillary. Some examples of action of capillarity are: a towel soaks up the body because towel has got small capillaries all over the surface. Ploughing of fields is important because the ploughing cuts out the capillaries in the field, so it prevents the field from drying. Sand is drier from clay because there is absence of capillaries in sand and there are capillaries in clay which draw up water and the clay is moist. We will see the rise of liquid in a capillary, which is called as capillarity. We take a capillary in a tub of water and that capillary ascends up to a height edge above the surface of the water. Now, as this is a wetting liquid, the meniscus is concave. So, at the point of contact, we have got tension which is downwards, and opposite to that tension is the reaction. The tension, if the tension is the action force, R is the reaction force. When we resolve this R into components along horizontal, we have got R sin theta, and along vertical, we have got R cos theta. R cos theta is the horizontal component, but it is along the vertical, and we say that along the vertical we have got R cos theta and along the horizontal we have got R sin theta. Similarly, this R has two components, R cos theta and R sin theta. R cos theta along the vertical, but it is a horizontal component, and R sin theta is the vertical component, but here it is along the horizontal. Now, we can say that this R sin theta and this R sin theta, these are equal and opposite along this whole circumference. As these are equal and opposite along this whole circumference, these R sin theta components cancel each other. But these R cos theta components are along the vertical and along whole circumference of this meniscus. So, this R cos theta, or the component of R, that is R cos theta, draws the liquid up as it acts along the circumference of the circle or along the circumference of the meniscus. The shape of that meniscus is concave. So we have R sin theta along horizontal, R cos theta along vertical. Now the total upward force is the components R cos theta along the circumference. That is R cos of theta into 2 pi r. 2 pi r is the circumference if r is the radius of this circle. Now, weight of liquid column of height h. The weight of this liquid column of height h is m into g, and we know that mass is volume into density. As this is of cylindrical shape, the volume is pi r square h and density is rho into g. So the components R cos theta along the vertical and along the whole circumference is balanced by the weight of this liquid column. So we can equate the two. That is, R cos theta into 2 pi r is equal to pi r square h into rho into g. Here 1 r and 1 r goes, pi and pi goes. So we have got h, height of liquid column, is equal to twice r cos theta divided by rho g into r. We also know that this is reaction force and that is equal and opposite to T, so their magnitudes are same. So we can also say that the height of the liquid column is 2T cos of theta by rho g into r. This is the ascent formula of a liquid in a capillary, but the liquid is of wetting type like water. The height is equal to 2r cos theta by rho g r or 2T cos theta by rho g r.